Hey everyone. I think we should kick up our session for today. Eric is going to be leading the session today. There is a bit of a presentation piece, but we're always open to questions and comments during the session. Feel free to speak up, raise your hand, or drop something in the chat. Eric is going to be taking us through feedback loops today, and not just the feedback loops themselves, but also the kinds of algorithms that inform how we can use feedback loops in order to get smarter models, as the title says, and also for business value. But without further ado, Eric, over to you.
Cool. I apologize if there's any background noise. There's a bit of rain in my house, but hopefully Google will automatically filter it out and you guys wonder what I'm talking about. So hopefully that's what's happening. Just get my screen share up first. Can you guys see the feedback loops slide?
Yes.
Perfect. So I'm going to be talking about feedback loops today, a fairly non-technical way, but still covering some slightly more technical topics. In the first part of the talk, I'll just be talking about like the concept of feedback loops and why we think it's very important and some different types of feedback loops. After that, I'll be explaining 3 algorithmic examples of how feedback loops can be used. I hope it's non-technical enough, but if it does get too technical, you can always ask simplifying or clarifying questions. So yeah, that's what I'm going to be talking to. And obviously, if you have any questions or anything, please just shout. And I'm sure if there's anything in the chat, Jess can just put it out to me because I can't see that meeting interface. Feedback loops, what do we mean when we say feedback loops? Feedback loops is a broader concept in how I'm going to be talking about it, but I'm going to be talking about it in the context that we work in and generally have discussions in these meetups, which is you have some sort of system that is interacting with a human, generally a customer or a client, but basically you have a human that's interacting with your systems. One way of doing that is you generate the interaction and the human interacts, and that's the end of it without the feedback loop. But what we think adds a lot of value is instead you have this loop where you have a human interact with your system. You then learn from that interaction, you use that learning to generate a new interaction, and then the human interacts with your system again based on this new interaction that you've generated. That happens in a cycle. One example of a feedback loop that I think everyone's probably heard of is if you were going to A/B test the color of a button. So you have a whole bunch of people interacting with your system, and some of them see one color button, some of them see others, and you learn from that. Maybe orange buttons work better, so you start showing more people orange buttons. So that's obviously a slightly delayed feedback loop. The concept is that you have these loops where you learn from how humans are interacting with your system in order to improve the way that your system interacts with people and hopefully improve the engagement that you have with the human in your system. So yeah, that's what we'll be talking about when we say feedback loops, the high level view of why they're important, because they allow you to improve and learn over time. Yeah, go ahead.
The way that we talk about feedback loops often feels like quite a manual process, right? So you put something out there, I mean, especially when we're taking an A/B testing example, you put something out there, you then let it run for a while, and then a bunch of people that decided they were going to test these 2 colored buttons get together again and then decide, okay, cool, we should go with this button over this one. Now, is that something very common, or is the automated part of it actually more important and useful?
So I think they both have their places. I definitely think that is more common, the sort of manual feedback loop. The automated one is a lot of what we focus on enabling, but can be more difficult for organizations to do on their own in a sustainable way. But both add value. So you can have different levels of feedback loop running simultaneously at different speeds. So you actually kind of want to have both. And I'll talk a bit in more detail about it later. What you want is both to be happening where your algorithm is learning automatically within the parameters that you set for it. And then the organization is learning at a slower rate and will effectively be adjusting the parameters of the algorithm based on those learnings. And when I say parameters, I don't mean necessarily the numbers that set how the algorithm behaves. It can also be the options, the things that the algorithm is allowed to recommend. So as a concrete example, you could have two messages that say get 10% off or click here to find out your discount. And you have an algorithm that's automatically optimizing the choice between those two messages based on the type of person who's engaging with the environment and a history, and it's choosing the best message for them. Those interactions are being displayed on a dashboard to someone in the content team, and they see like, oh wow, this click here to find out your discount is generally doing a lot better. Maybe we should try some variations on that, or maybe we should build some more of that into our product, or add more features along that vein. And they can add different things that the algorithm can recommend and talk about, and add those into the configuration, and it can optimize on those new options. Those two levels are both very helpful, and it's actually great if they work together. I mean, of course, you can also have the one in the middle that's like an agentic structure of framework that's generating content for the algorithm without human review. But in the industries we are generally working in, the regulation and risk level isn't quite there yet, but it's definitely another level that could be there, is, have the algorithm generate new messages based on have the second level of algorithmic feedback generate messages based on what the first level is seeing, and then have an organizational learning that maybe setting the guardrails for the agentic piece. I don't know anyone who is yet willing to expose generated content to their users without it first going through some sort of manual review process, like in the industries that we're generally working in. Does that make sense, Jess? Answer your question?
Yes, absolutely.
Okay. So the next thing I thought I'd talk about is, why are feedback loops important? So, like I said, at the high level, it lets you improve your engagements, but you can think about it more deeply than that. There's a few points that are particularly relevant here. The first is, and this is something we say a lot, but human behavior is dynamic. In most circumstances where you have a system engaging with people, the way that people behave changes over time and changes on a relatively short loop. And you want to be able to adjust to that feedback. So even if your system is engaging well with people now, as that behavior changes, if you can't learn from that feedback, the quality of those engagements will deteriorate. And that could be done through the algorithmic feedback loop that I was talking about, or it could be that you have a more manual process and you know that every week you need to go in and adjust things. For every type of feedback loop, it's relevant that human behavior is dynamic and changing, and it's something that you need to be aware of and take into account as much as possible. Related to that is the fact that context changes. That will also change the effectiveness of how you're engaging with people, and it will influence the human behavior that you're trying to interact with. You need to be able to pick up those changes, learn from them, and adjust the way that your system is engaging. The only way to do that is with some kind of feedback loop. The more responsive that feedback loop is, the more quickly you can adjust to those changes in context. The next one is that the next two are related to information. So the first one is, even if you have a lot of information about your system when you set it up, you can always learn more. Like, you're never going to have perfect information about your system and environments. Things will be changing, but even if they're not, you can still learn more about a static environment and improve your engagements based on those learnings. And then the other information piece related to that is, if you have a rapid feedback loop, you can actually start your engagement and learning process with very minimal information. Another kind of analogy for that is in the software development world, where you have the MVP process, where you, even though you don't, you kind of know that you don't know a lot about what's going to work, go out with this kind of product that is incomplete and imperfect, but you know you're going to be able to learn from the way it performs and add new features based on what's working and what's not. So you can have that sort of feedback loop, but it also means that if you want to start adding some intelligence to the messages that you're sending to people, even if you have very little data on those people available to you, you can start learning. And if you have a rapid feedback loop that you can use, you can very quickly build up that information and learning and improve the intelligence of the way that you interact with people. And I think the faster you can get that feedback, the less information you need to start with. So, in a traditional data science project where you're going to build a big model to predict things, you need a whole bunch of data, and you train it and check the results and see how everything's performing, and then you deploy it, and it should perform relatively well because you have all of this setup. But it takes a long time to get started. Whereas if you have a quick feedback loop, then you could potentially start with less information and learn over time, rather than getting all the information first and then doing the implementation.
Eric, Nicola's got your hand up for a question.
Okay, go ahead.
Hi, sorry, I forgot you can't see me. I don't want to derail it. You mentioned a few times rapid feedback loops and fast feedback loops. I'm assuming that means quick learning and taking the information that the customer is giving you very seriously, updating your beliefs about them significantly in the beginning so you can gather as much information from them as possible. And then as interactions go on, you want to maintain some kind of consistency. You don't want your feedback loops to bounce around from one thing to the next based on whether someone just says, oh, actually, I don't want this. Maybe it's just because they pressed something by mistake. Who knows? How do you know when to take certain feedback seriously and some not?
Yes. So I think two things. The first thing is, I think you need a rapid feedback loop. If it's going to be quick, you need to get the data. Was my interaction successful or not? Which sounds trivial, but in a lot of organizations can be complicated. You have to be able to get the data, then you have to learn from the data, and then you have to act on that learning. In the case of messages, it's like, okay, going back to the 2-message example, like which message, I need to know which message worked best. I then learn how much more I should be sending one message than another, and then I need to actually send that message more. You need those 3 points of action to be rapidly implementable. Get the actual data, quickly learn, and quickly take action based on that learning. In terms of stability and speed of learning and all of those sorts of things, there's kind of approaches where you would like take history into account in a tapering way. As someone starts off, you try and learn relatively rapidly, and then the history has a lingering effect, so you don't immediately bounce around to new options. But there is also a component where the product owner or the content person or whoever it is setting up if it's an automated feedback loop, this is kind of the assumption, then they can, with the parameters that they set for that algorithmic feedback loop, they can set how rapidly it learns and converges. The other problem besides it bouncing up and down is that it just fixates and like it learns a bit in the beginning and then just sticks on that thing that seemed to work the best forever. So you need to, and that's why like generally kind of running a simulation or having a simulation to start off, but also having the manual feedback loop at the same time as the automated one is important, so that you can see like, oh, okay, yes, actually it's learning, but it's learning in a very noisy way where it just follows the trends, or it's got stuck on the average option and we need to adjust the way that that's happening. So there's definitely a design component to how you want that learning to happen. Like the question of where you start off and you have few interactions and then you get more, there are approaches to handle that in an automated way, but you would need to do some manual checking and validation that the system is behaving in the way that you would want it to and that you think is effective in driving your engagement. Does that make sense?
Yes, definitely.
Any other questions before I carry on?
Yeah, I was curious regarding where most companies, and I mean, you can honestly, if you don't know this, and you don't have to answer the question, but I'm looking at these points here and the importance of these feedback loops, and it feels like there's probably a lot of businesses out there that are not using this. Can you maybe speak to what some of the shortcomings are in current businesses with regards to the implementation of feedback loops?
I think most people do this to some degree. You can even think of calling to ask someone for their net promoter score, where they're like, how likely are you to recommend ecosystem AI to a friend? You can see how things are working or not. Even that is a type of feedback loop. I definitely think there's room for improvement, especially a lot of more traditional companies. I think, and I don't think it's a lack of knowledge that it's important or desire to do it. I think a lot of the time people get stuck in the technical constraints. Those three pieces that I was talking about to Nicola of like actually get data to see how things are working, learn from that, make the change, can be quite daunting if you don't have the right sort of environment in place. And often, if it's very hard to do that, then maybe the benefit you get from improving your engagement isn't worth it because it's taken you millions of rands worth of employee time and effort to run that loop, and it went over 6 months. So it's out of date by then anyway. I think the concept of feedback loops, most businesses would understand and would want to implement. You have to have the right tools in place to do it in a way that doesn't erase the benefit that you get, either because it takes too long and the feedback is then irrelevant, or because it costs so much to get the feedback that any benefit you get is wiped out from all the time and money you have to spend getting it right. Does that make sense?
Thanks.
So we've spoken about this through the questions as we've been going along, but I thought it's important to point out there are different levels of feedback loop which serve different purposes and kind of, I think, can, if they work together, can enhance each other quite effectively. So like I said, there's also a potential agentic loop you can add in here, but for the loops that are available or feasible today, there's the algorithmic loop. So that is like automated learning from feedback and adjustment of the way your system is engaging based on feedback, ideally in a real-time way where you're learning from each interaction and adjusting the behavior of your system based on those learnings. And then there's what I call an organizational feedback loop, which has a much slower timescale. You expose the results of your algorithmic loop to the organization, so the content team or the product team can see what is proving effective or not in the algorithmic loop, and then come up with new things for the algorithmic loop to test or adjust the parameters of it so that it is learning in a different way, or make whatever other adjustments need to be made in order to improve that overall behavior of the system. So yeah, like I said, we've spoken about that a bit through the process, but I thought it's worthwhile to reiterate. For the rest of the session, I'm going to be talking about a few examples of algorithmic feedback loop approaches. So I don't know if there's any other questions on the organizational side or how they interact together before we move into that part of the session.
I did have one question with regards to the roles that would own this, but I feel like, yeah, I don't know, it might have already been answered in some way, but maybe you can speak a little bit to that.
Yeah, so ideally you would have two roles involved in the organizational loop. One would be your data scientist style person. That would be someone looking at Nicola's question of, is the algorithmic loop learning in the way that we wanted it to? Should we be adjusting how much history it's taking into account and how it's taking that history into account? And you'd also want to have the product or content owner involved. If what's being fed back on is marketing messages, you would want the marketing content team to be involved. It's something I always bring up. Product design space, I always found it kind of frustrating that you make all these decisions and only have visibility of the effectiveness of the path that you choose. You never get to learn like what would have happened if I'd gone the other way. But if you can have this automated kind of feedback experimentation approach, you can actually see how well all the options you test would work, and that can then inform what you design and build in the future, whether that's designing and building app features or writing content in different ways for different types of people. It's the people who come up with the ideas and create the product who can have a big impact if they are part of that organizational learning loop, together with the more data analyst, data science focused person. The more you have it, the better. It's not like it doesn't work if they're not all involved, but if you can have all of that happening at once, you can have quite an impactful system and learning environment.
Thanks.
Cool. I thought it would be interesting to talk about different ways that algorithmic feedback loops can work. And I'm going to talk about 3 different approaches that are available in the ecosystem environment: the Epsilon-Greedy, the ecosystem rewards, and the Bayesian Probabilistic Approach. There are a number of other like dynamic learning feedback loop approaches, both in our platform and generally available. But I think those 3 give a good view of kind of a few different types of ways that feedback loops can work algorithmically. But before I talk about the specifics, a key concept that underlies a lot of them is the explore-exploit trade-off. I've spoken about it before in some of the meetups, but I think it's worth recapping to provide a foundation and some context for the details of the algorithms themselves. The explore-exploit problem is basically how much of your resources you spend learning versus making use of what you've learned. Explore is learning and exploit is making use of what you've learned. Every interaction that you have with someone is an opportunity. Do you use that opportunity to test a new idea or find out something new, or do you use it to do what you think is the best thing given your current state of knowledge? So to go back to the message example, if I've got those 2 messages and I know that find out your discount performs as a 60% take-up rate and we'd like to give you 10% off as a 40% take-up rate. Obviously those are crazy high, but to illustrate the point, do you say like, oh well, I've seen that find out your discount has a 60% take-up rate, so that's the best one, so that's the only one I'm ever going to show from now on? Do I say, I wonder if people have gotten tired of that message, or it's more appealing at certain times of days, or a competitor has launched something that speaks in a similar tone of voice and something contrasting would work better? Do you try the other message, even though you can see from your data that on average so far it's performed worse, because you want to check if that's still the case? A lot of these algorithmic learning feedback loop approaches are at their root about how do you make that trade-off? When do you explore? When do you exploit? And what is the balance between those 2? The first approach is called Epsilon-Greedy, and it's the simplest approach. And in that approach, basically, as the person setting up the feedback loop, you decide how much exploration versus exploitation should happen by saying that I want epsilon% of interactions to be explore and the rest to be exploit. So say you set epsilon to 10%, that means that 10% of the time the system will learn as much as possible, and 90% of the time the system will use that information that it's learned as much as it can. So what that comes down to in practice is when you're generating an interaction with the system, so say I log into the app, you will say, is this part of the 10% or the 90%? Or the algorithm will check, is this part of the 10% or the 90%? And if it's part of the 10%, it will generate that interaction at random. So to go to our message example, we'll just pick one of the two messages at random, show that, and record the results. If you're part of the 90%, it will then say, okay, I'm going to use the knowledge that I have and show the best performing message. So if find out your discount is doing the best at that point, it will always show that message to 90% of people. You exploit your knowledge in 90% of the cases and explore in 10%. That exploration is providing you with your feedback mechanism because you're testing things at random. If one message starts performing better than it had before, over time, your random offers will pick that up because you will, and the higher that you set epsilon, the faster you'll pick it up. So that's the trade-off you make when you're setting up this algorithm, is you say, how quickly do I want to learn if something's changed? So how many of my interactions do I want to dedicate to learning, even though they might be suboptimal in the short term? Over the long term, it will allow my system to perform better. So by gathering that data on how effective your random interactions were, you can then learn what is working the best and then make that adjustment so that in your 90% of cases, or 80 or 70, however you set it up, you're showing people the best performing offer that you have. That's the simplest kind of algorithmic feedback loop you can set up. It's simple, but it can be quite effective. The nice thing about it is it's easy to understand, configure, and understand what it's going to do and also what's happening in the system. It's very straightforward to keep track of and explain to people why it's doing what it's doing. The downside is you have to pick the right value of epsilon. So you have to make sure that you aren't learning too much or too little, which can be challenging. Generally, people use that value, which can be effective, but yeah. So yeah, that's Epsilon-Greedy. So I don't know if there's any questions on that before I move on to slightly more complicated approaches.
Mine's
Eric, the explore-exploit ratio, is that like a configuration, or is it also something that can change dynamically based on what's being observed in terms of the feedback loop?
In this approach, it's a configuration. This Epsilon-Greedy algorithm, it's a parameter that a user sets to say, I want epsilon to be 10% or 20%. And they can change that. So the organizational feedback loop can change it. But the algorithm doesn't decide what epsilon should be. Yeah. So the next one is ecosystem rewards, which if anyone wants to read further about it, uses an approach called Thompson Sampling. But basically what we try to do here is to say, can we have a distribution that indicates how effective an offer is? If that distribution is more over to the right, you can see here that distribution is more shifted over to the right. So we believe that offer is more effective. If it was over to the left, it would be less effective. So you could think that, let's say that peak of that distribution is at 70%. We kind of think on average that offer has a 70% effectiveness. If it was more to the left, it would be 20% effectiveness. How wide the distribution is gives us a measure of how certain we are in our belief that that is the case. So if you have, the bottom right, we have a fairly high degree of certainty about how effective it is. At the bottom left, we are pretty uncertain about how effective it is. So the idea behind ecosystem rewards is, can we have a distribution that represents our knowledge about how effective each option is? If you start off with no information, so You're going to have your distribution that's right at the top there, which is you have no information. So you just have a straight line. You don't know whether it's 0% effective or 90% effective or 50% effective. Everything is equally likely. And in order to decide which offers to choose, you pick numbers from those distributions. If you have a straight line, you basically pick a random number because you have no information yet. And then as you engage and build up information, as some things work better or worse, you build up your distribution representing your knowledge. The more times you've recommended an option and someone's engaged with it, the more peaked your distribution is going to be. You have more certainty about how effective that offer is. And the less times you've recommended it, the broader it will be because you're less certain about how well it works. So that option on the bottom left has been shown less than the one on the bottom right. And what this gives you is what Moritz was asking about, an automated way to balance exploring and exploiting. Because if you compare those two distributions on the bottom left and the bottom right, those have the same average given the knowledge that we have. But the one on the right could have a much higher number chosen from it. You can see there's much more space on the right-hand side. That could also have a much lower number chosen. So there's more variability in whether you're going to choose it or not. Whereas the one on the right is kind of narrowing down and we're fairly shit and that this is how effective that offer is. The way that it chooses is based on a combination of how uncertain you are. So the more uncertain you are about something, the more likely you are to choose it, and the more effective it appears to be, the more likely you are to choose it. Something that is effective and you're quite uncertain about will have a very high chance of being chosen again because you want to compare it well to other things, whereas something that is ineffective with high certainty will be very unlikely to be shown again. By building distributions about the different options, you automatically balance that explore-exploit trade-off, which is quite a useful bit of capability. And it's why this approach is proven to be quite effective in practice, even though its underpinnings are relatively simple. You have these basic distributions of each option, and then you pick a number from each distribution. The higher the number, the higher the rank. Doing that allows you to balance your explore and exploit in an automated way and adjust that over time. If you have something that works really well, you'll almost stop exploring because or you'll explore significantly less because you know that this looks like a really good option. And then if that shifts, you'll start exploring more again to find what's working. So that's why this approach can work quite well.
I wanted to check my understanding quickly on this. It sounds to me like there's two very distinctive ways that you can approach using ecosystem rewards from a configuration level. The first would be to drive a higher level of certainty. You start off with a hypothesis and guide it into a direction. And then on the other hand, you've got obviously then the no information about how effective an option is. You let it learn on its own.
So you can do both of those. So you can start it off with a state of belief or state of knowledge that then it will adjust over time. If you believe that one thing will work much better than the others, you can start it off with that knowledge and it will try that option more. But if it doesn't work, it will gradually adjust to offer it less and less in an automated way. But yes, you can do both of those. And so something that can also work quite well if you have an existing environment with knowledge and you want to introduce a new product or message and you want it to be tested. Instead of starting it off random, you could start it off with a shifted distribution so that it will be tested more initially. And if it doesn't work, it'll quickly shift back. But if it does, then you haven't wasted time waiting for it to randomly be shown.
Okay, so one of the things I was wondering about with the previous one is that depending on how many options you're testing, that would define how you set the epsilon, right? But with this one, it doesn't matter how many options you have, but also the kind of timeline that you have. If you start with a hypothesis, it's more likely that it's going to get to a point of higher certainty versus when you have no information, and it'll take a longer time frame in order to get to that high certainty.
Yeah. So it's about the number of options you have, but also how different those options are. So if you have 3 options and one of them is much better than the other 2, you don't need that much learning to recognize that and have that happen. That's why this approach can be nicer than the fixed epsilon one, because in the fixed epsilon one, you don't know that going in. So you have to just say, okay, there's 3 options, so I'm going to set epsilon here. With this approach, if the difference in the effectiveness of the things you're testing is large, then you need less learning. It will automatically pick up on that and learn less and start exploiting more when it's confident that this one option is significantly better than the other 2 that are in the set of things it can look at.
Okay, thank you.
Good. Okay, and then quickly, because I see there's just 5 minutes left, the last option is the Bayesian probabilistic approach. So this is based on what's called a naive Bayes classifier, which is then based off Bayes' theorem. So this is more similar to your traditional static model based approaches. You have a bunch of features and you're learning what to recommend based on those features. To give an explanation of first of just how Bayes' theorem works, and then that will feed into how the classifier works. So Bayes' theorem is a way of, like I said, updating your knowledge about a system based on new information that you get. To give an example, say that you have 2 bowls. There's a blue bowl and a green bowl, and they have cookies in them. The blue bowl has 70% chocolate chip cookies and 30% oat cookies, and the green bowl has 30% chocolate chip cookies and 70% oat cookies, right? And that would be an analogy of your feature. Is the cookie a chocolate chip cookie or an oat cookie? And then you take a cookie from a bowl, but you don't know which bowl it is. So all that you know is before you take the cookie, it could be either bowl. So you have a 50-50 belief that this is the green bowl and a 50% chance that it's the blue bowl. And then if you take a cookie and you see that it's a chocolate chip cookie, your belief that the bowl you're taking cookies from is the blue bowl should go up, because there are much more chocolate chip cookies in the blue bowl than the green bowl, right? So as you get more chocolate chip cookies, your belief that you're taking cookies out of the blue bowl will get higher. And Bayes' theorem is a way of quantifying that change in belief. If it's 70% and 30% and I get 1 chocolate chip cookie, my belief that it's blue should go up, but how much? And I won't go into the theorem, but that's basically what Bayes' theorem does, is it tells you like how much it should go up. That's then through some maths changed into the naive Bayes classifier, which I did put one equation in the slides, which is one at the bottom of there, which will basically say like, okay, what's my original probability of having either of these bowls or either message working? So say it's 50%, and then your X's there are your features. What is the probability of getting a chocolate chip cookie given that it's the blue bowl would be your feature. And then it could be, what is the probability that I responded to this message if it's over lunchtime, or the probability that I responded to this message if I opened my account within the last week, or whatever features that you're using are. If you multiply all of those together, you get your total probability that this option is effective given the data that you have or the features that you have. So you do that for each of your options, and then you have a ranking of them that you can use. There is an assumption behind it that your features, your X's, are what's called independent. To give the 2 that I gave, the time of day, the fact that it's lunchtime, and the fact that you opened your account within the last week. The algorithm actually still works if that assumption isn't valid, which is kind of a helpful thing in practice. But theoretically, that's the assumption that's used to derive the algorithm. But it works without that. Because it's relatively simple, you can actually do this learning and scoring in real time, which is what prevents a lot of traditional static models from being used in these feedback loops. And then you can add similar things to what we were talking about before to enable exploration, where if something has never been shown, give it a random distribution and sample from that in order to decide whether to offer it and things like that. But yeah, so I have 30 seconds left. So that's effectively how the Bayesian probabilistic classifier works. I don't know if anyone has any questions. We
No.
close off.
I just wanted to let everybody in the call know that Madison has dropped a link in the chat to our next session, which is going to be our tech session. So this was our business session here. If you click on the link, you'll then attend our feature engineering session that we're doing just after this. And then, Eric, I was hoping you could just spend like, I don't know, 2 minutes maybe to give us a tangible example of when in common environments that people would know, Bayesian has or could be used, and the same with ecosystem rewards and with Epsilon as well.
Yeah, so I think Epsilon you generally only use if you want something quick and easy to understand to set up. So it's kind of like you're testing the waters almost in a lot of cases. So it's easy to get through all the committees and things. Well, not easy, but it's easier because it's easy to explain what it's doing, but it still provides you with that automated functionality. So that's kind of when I would do that. I think ecosystem rewards is quite broadly applicable, where you don't think there's a lot of context, but there's not a lot of different data points about the customer that you think will impact their behavior, or you don't have that much data. So potentially something with new customers or logged out users, something where you think the customer behavior is only going to be impacted by a few features rather than a larger set. Naive phase would then be when there's more data that you think is relevant to selecting the best engagement, something like a logged in user with a lot of history and a lot of variability in how people will respond to the engagement that you're generating.
Amazing. Thank you. That was actually really great, and looking forward to more. Otherwise, guys, everybody else, will see you on our tech session next. Thank you all for being here. Bye.